Hello students, welcome back to my channel NJ Math World. Today I am going to solve first semester BCA examination January 2025 SCP syllabus freshers computer application paper is computational discrete mathematics. So yeah, the paper will be for 3 hours and the maximum marks will be 80 for the paper. So yeah, instruction, answer all the sections. We have to answer all the sections. So now the section A. What is section A? In section A, you have answer any 10 questions. Each question carry 2 marks. So we are going to answer any 10 questions for the given question. They'll give you 12 questions. You have to write only 10 questions for the first minute. That is section A. So let us start. Define converse, inverse, and inverse of an implication with an example. We have to find converse, inverse of the given with the respect to implication. So yeah, I'm going to do contrapositive for your reference. Consider the condition P implies Q where P and Q are any two proportionals. Then we have Q implies P is a converse of P implies Q. What is converse? Converse is Q implies P is a converse of P implies Q implication. The preposition negation P implies negation Q is inverse of P implies Q. Then the preposition negation Q implies negation P will be contrapositive of the statement P implies Q. So for example, if they've given P is if it is sunny outside, sunny outside, then Q is then I will go for a walk. So what will be Q implies P? Here it will be if I will go for a walk. If I will go for a walk, then we have to reverse the sentence. Then it is sunny outside. Sunny outside. Now, next one is inverse negation Q. Negation P implies negation Q. Negation is nothing but writing or not in the given statement. So, yeah, for P, negation P means if it is, if it is not, you have to add not sunny outside, then I will, again you should add not, I will not go for a walk. It will be negation P implies negation Q. Then what will be inverse? Inverse will be negation Q implies negation P. So we have to reverse this sentence what we have written. If I will not go for a walk. If I will not go for a walk, then it is not sunny outside. So these are the three different prepositional conditions which they may ask in any of the paper. Then moving on with the next question we have define tautology and contradiction. What is mean by tautology and contradiction? Tautology, a statement that is always true regardless of the truth values of its components. So all the values in the truth table should be true, then it is called a tautology. Contradiction, a statement that is always false regardless of the truth table of its components. So the values, if all the values are false in a truth table, then it is called as contradiction. And if you have a mixture of both, it is called contingency. If you have both true and false in one table, it is called as contingency, where you'll have true and false together. Okay. Then moving on with the next one, we have defined identity matrix. What is mean by identity matrix? Identity matrix is a square matrix in which all the diagonal elements are 1. So this is called diagonal element. So the diagonal element should be 1 and all non-diagonal elements are 0. So leaving the diagonal, all others should be 0. And here this is also called as unit matrix. It can also be called as unit matrix. Okay. Then next one we have define pigeonhole principle. What is pigeonhole principle? If n items are placed into m containers where n is greater than m, then at least one container must contain more than one item. For example, if you have one, two, three pigeons and you have only two holes, that means what? One hole will contain at least more than one pigeon. That will be n should be greater than m. Okay. So here that is called as pigeonhole principle. Example, if there are 10 students and 9 desks, means what? In one desk you'll have two students extra. Na? In one bench there will be two students. Okay. So here at least one bench should have more than one student in it. That is called pigeonhole principle. Next one you have 8c2. What is 8c2? 8c2 is combination, that will be 8 factorial divided by 8 minus 2 factorial 2 factorial. That will be 8 factorial is 8 factorial divided by 8 minus 2 is 6 factorial 2 factorial. So 8 can be written as factorial means writing it in reverse order. 8 into 7 into 6 factorial divided by 6 factorial into 2 into 1. So 6 and 6 get cancelled. 2 ones are 2, 2 fours are 8. So totally 4 into 7, 4 sevens are is 28. So the value for 8c2 is 28. So moving on the next question we have, what define the principle of induction and inclusion and exclusion. Define the principle of inclusion and exclusion. So the principle state that for any two finite set A and B, A union B will be equal to A plus B minus A intersection B. That will be if A is 5, B is 4, A intersection B is 2, then the answer will be 5 plus 4 minus 2. That will be 9 minus 2 will be 7. Now, principle of inclusion and exclusion for three set A, B, and C can be written as A union B union C will be A plus B plus C minus AB AC BC. Two terms. First, you will take one term, then you will take two term. Whenever you are taking two terms, it is negative. Then plus you should take three terms. A intersection B intersection C. If union is in this and then the intersection will come in the last. Suppose if you have in the question intersection is nothing but finding common. Here it will come union. It will be vice versa. Reverse. Okay. Then moving on with the next question. Define a strong induction and a weak induction. What is a strong induction? Proves a statement Pn is true for n is 1 and assumes that pk is true to prove pk plus 1 is true. Then what is strong induction? Assuming pj is true for all j less than or equal to k value to prove p of k plus 1 is true. The difference between them is strong induction uses the assumption of all paired steps, while weak induction uses only the immediate paired step. Here we will be including all the steps. Here it will be only paired beginning step. Okay. Then what is mean by question number 8? Define relation and function. What is a relation? A relation is nothing but one to one connection. That is a relation are between two set. If you take us two set A and B, A is 1, 2, and B is 3 and 4. So, yeah, the Cartesian product of A and B, for example, it is a relation R between set A and B is subset of a Cartesian product A cross B. So, here, for example, if A is 1, 2, and B is 3, 4, then we can write it as 1, 2, 2, and 2, 2, 4. So, that will be the relation, for example. Okay. So we'll be writing the first element from domain and second element from codomain. This one is called domain and this is called codomain. So always you'll have a set of domain and codomain elements, second one. Okay, then, or it is also called as a range. The connection between the first element to second element will be also called as a range. Then, function, a special type of relation where each element in A maps to exactly one element in B. So, for example, f of x is equals to x square. So, now if I take x and then the x square, if x is 1, 2, 3, what will be square of 1? 1. Square of 2, 4. Square of 3, 9. So every one element will be connected with every other element in the domain and codomain. Then, moving on with the next question, we have write any two write
Functions.
any two types of functions. What are the two types of function? The two types of function are one to one function, injective, one on to function, surjective. What is injective? If every element in a domain maps to a unique element in codomain, that is, if every element of domain must have one and only one image. If it has one and only one image, it is called as one to one function. So, for example, you have 1, 2, 3, you have A, B, C. So, every element of domain should have one and only one image. Then it is called as 1 function if it is one and function. Then, what is on to? Every element in a codomain has at least one pre-image in the domain. It can have one and it can have more than one pre-image. Pre-image, this is called image. These are called image, and this are called, the elements in domain is called as pre-image. The element in codomain are called as image. So here it says every element of codomain, that is 1 2 3 4. Here we have 1 2 3 4 5 6. So it says every element of codomain should have one, at least one pre-image. It can have more than one also. So then it is called as onto function. Okay, then it is called as onto function. Then moving on to the next one, what is a graph? A graph is nothing but a set of vertices and edges. What is mean by vertices? Vertices are points and edges are lines. So if you have points and lines connected in a graph, then it is called as connected. Then it is called as graph. For example, if you have A, B, C, D, A, B, C, D. They are four vertices points. Then it is connected with each other. Then that is, it says here edge is having, where is the edge? Edge is from A to B, one edge. Then B to C, we have another one. So this is the graph for the given data. Okay. Then moving on with the next one, we have what is a graph isomorphism? Isomorphism is nothing but if a graph G1 and G2 are isomorphic, if they satisfy one corresponding between their vertices and edges, preferring adjacency. If a G1 and G2 have the same structure but different vertex label, there are also isomorphism. Here, what is isomorphism condition? Here we have number of vertices of the both graph must be same, number of edges in both graph must be same, degree sequence of both graph must be same, and it should be written in ascending order. If the first graph is formed by the cycle, then the length of it will be v1, v2, v3. Then the other graph must also be in the same cycle length. K is equals to v1, v2, v3, etc. So this is a small example for isomorphism. Moving with the next question, we have defined Euler path. An Euler path is a graph. Is a In a graph is a path that visit every edge exactly once. In a graph with the vertex A, B, C, D, and a Euler path could be A to B, B to C, C to D. Proves provided by every edge is connected only once. So, or you can write Euler path is in a graph is a path that visit every edge of the graph exactly one. At it may or may not return to the starting point. So, for example, I am taking from E. So, I am going from E to B. then A to B, then B to E, then E to C, then C to D, and then D to E. So it is visiting all the edges only exactly one time. So moving on with the second main, section B. Second main, you have to write any six. Each question carries 5 mark. So here first one, prove that they have given logically equivalent. We have to prove they are logically equivalent. Okay. So here P or R. R is nothing but F and F. It is F. So let me check where is F and F for P and R. P and R, Q and R. So yeah, Q and R, where you have a T and T, we have to check. So in the second and third line, so you have a T and T. Yeah, we have here. So it will be F. Then we have in the last. Then it will be all F. The remaining will be 2. Then next one is P implies this one. That is, we have to see in the first line and the fourth line. The condition is implication. Implication means T F, it is F. Or means it is F F, it is F. Now next one we have P implies Q. We'll check for the condition T F F. Where do we have T and F in the first and fourth one? T and F, T and F. We have here T and F. It will be F. Then we have again, no, we don't have, the remaining all will be true. The remaining values are true. Okay. Now negation A. What will be negation A? Negation A will be whatever we got here in the fifth bracket. We have to write the negation of that. It is false. False. T means F. F means T. So false, false, false. T, F, 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 and F. Okay. So now moving with the next one, we have next one is negation Q. Negation means T T F F. So we'll write T T F F. T T F F. Then we have R. Negation R will be TF TF. Third line TF TF. So we'll write FT 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 FT. Okay. Now we have to take and for this both. And is what? It is T and T. It is T. Otherwise it is false. So T and T, it is T. Then you have T and T. It is T. Otherwise it is false. Otherwise it is false. Then P and P. P and B is first line and B is this line. We have to check for and is T and T, it is T. So it is T and T, no, 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 T, F and N. We don't have that condition, so it will be all. It is we have to check it for this line, that is a negation, this line, and we have to check for this. It is a F F F, then it is T, that is fourth one is T, and here it is F. So it is again F F F F, and again it is F. So we can see they are not logically equivalent. The values are different in the answer, so it is different from each other. So we can write this second one and this last line, comparing them, we can say they are not logically equivalent. Then moving on with the next one, find the inverse of the matrix. What is mean by inverse? Formula is A inverse is equals to 1 by mod determinant of A into adjoint of A. So now let me find the first determinant of A. What will be determinant of A? Determinant of A is 1 2 1 5 2 5 2 3 1 and 3. So here determinant of this will be plus minus plus. So you have to take, whenever you select this, that first row and first column you should leave. So it will be plus 1 into 2 3s are 6 minus 3 1s are 3. Then you'll go for the next one. Select your next one. So that will be center one. And find the answer. It is minus 2 into 5 3s are 15 minus 3 1s are 3. Then last one we take last one, last digit. So that is this and this one. So we have plus 1 into 5 ones are 5 minus 2. So here the answer will be plus 1 into plus 3 minus 2 into minus 11 14, no 13 12 minus 12, then plus 1 into plus 3, so it will be plus 3 ones are 3 minus into minus plus the 12 twos are 24 plus 3 ones are 3, so it will be how much? uh, 20 30 24 30, so 30 is not equal to 0, therefore a inverse exist. A inverse exist. Then next question is, we have to find inverse. We have to find adjoint of this. Adjoint of A. How to prove that? We have to find the adjoint. To find the adjoint, first we will find the cofactor. Cofactor. What is the cofactor? Cofactor can be find for the matrix in this way. You will write plus, minus, plus determinant, minus, plus, minus, plus, minus, plus. So we'll be finding the cofactor first. What is a cofactor now? Cofactor is nothing but we'll select the first element. Whichever element we'll select, that row and that column we will leave. And the remaining elements we'll write it in this one. The first element means here in the first place I'll write 2, 3, 1, 2. Then I'll select second element. If I'm selecting second, that row and that column I should leave. So to leave 5 3 1 2. Then when I'm taking third element, I have to leave that row and that column, so it will leave 5 2 5 5 2 1 1. Then we'll go for the next line, so we'll take the next line now. So to next line I'm taking 5, so that row and that column we should leave, so that row and that column 5 if I take, certainly 2 1 2 1 1 2. Then we'll take 2, that row and that column you should leave, that will leave 1 1 1 2 1 1 1 2. Then you'll take the third element, that row and that column you should leave, it will leave 1 2 1 1. Then you'll go for the last line, that will be 1. So if I take that line, that row and that column you shouldn't leave, certainly 2 1 2 3. Then you'll take second element, that row and that column if you leave, it will leave 1 1 5 3. Then you'll take the last element, so that row and that column you leave, it will leave 1 2 5 2. So now find the answer for this, or how you are going to find the answer for this. The answer will be finding the determinant of it. What will be determinant of the given cofactor? You will find it as, cofactor will be, you'll just find it here only. I'll just do it for this. Certainly here 2 into 2 will be 4. Certainly 4 minus 3 ones are 3. Then minus 5 twos are 10. 10 minus 3 ones are 3. Cross multiplying. Then plus 5 ones are 5. 5 minus 2 ones are 2. So yeah, 1 fours are 4, minus of 1 fours are 4 minus 1 ones are 1. Then plus 2 ones are 2 minus 1 ones are 1. Then minus 1 ones are 1 minus 2 ones are 2. Then here last one, 1 2 threes are 6 minus 2 ones are 2. Then minus 3 ones are 3 minus 5 ones are 5. Then plus 1 twos are 2 minus 5 twos are 10. So we are just finding the values for that. We'll just write it in the form of cofactor now. What will be cofactor? Cofactor is the answers what we got. Certainly, I'll simplify here. It will be plus 4 minus, it will be 4 minus 3. 4 minus 3 is 1. So plus 1. So plus into plus will be plus, it will be 1. Then we'll go for the next one. It will be minus of 10 minus 3 is 7. So it will be 7. No sign means plus. Plus into minus is minus. So it will be minus 7. Then we'll go for the next one. Plus 5 minus 2 is 3, certainly plus 3. So plus into plus is plus 3. Then going with the next one, we have minus of 4 minus 1 is 3, certainly plus 3. Plus into minus will be minus, certainly minus 3. Then going with the next one, it is plus 2 minus 1 is 1. So no sign means it is plus. Plus into plus will be plus 1. Then you'll go for the next one, minus of 1 minus 2 is minus 1. Minus of minus will be plus, certainly plus 1. Then 6 minus that is plus 6 minus 2 is 4, so totally plus 4. Plus into plus is plus 4. Then you have minus of 3 minus 5 is minus 2. Minus and minus become plus, so it will become plus 2. Then the last my plus of minus 8, so totally plus into minus is minus 8, certainly minus 8. So now whatever we have got, if you take that as inverse, that gives you the adjoint of A. So what is adjoint of A? Adjoint of A will be 1 minus 7 3 and minus 3 1 1, then 4 2 minus 8. So this is your adjoint of A. Now what we should do? We have to just write for finding A inverse. What we are supposed to write? We are going to write A inverse will be A inverse will be, I just write here. Okay, let me check. Let me write it here. A inverse. I'll write the answer here. A inverse. What will be A inverse? A inverse is 1 by determinant of A into adjoint of A. So the answer will be, the answer is it is here 30. So it will be 1 by 30, 1 by 30 and into this 1 minus 3 4 minus 7 1 and 2 3 1 and minus 8. So this is your inverse of A, the matrix A. Okay, moving on to the next question. We have, they've given in how many ways a committee consists of 4 men and 2 women can be chosen from 6 men and 5 women. So we have 6 men and 5 women. We have to select 4. We have to make a committee of 4 men and 2 women. So yeah, we have total is, this will be n and this will be r values. Certainly the first set, if you take it is NCR means 6C4 into second element, if you take it is 5C2. So simplify this 6C4 into 5C2, that will be 6 factorial divided by 4 minus 6 minus 4 factorial into 4 factorial, then into 5 factorial divided by 5 minus 2 factorial 2 factorial. So that will be 6 factorial divided by 2 factorial 4 factorial into 5 factorial divided by 3 factorial 2 factorial. So that can be written as 6, it can be written as 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. Then into 5 can be written as 5 into 4 into 3 factorial divided by 3 factorial into 2 into 1. So 3 and 3 cancel here, 4 and 4 get cancelled. 2 one time, 2 3 times. Send 2 one time, 2 2 times. So it will become 3 into 5 is 15 into 5 into 2 is 10. So the answer will be 150. So how many ways we can form the committee? We can form the committee in 150 ways. Okay, moving with the next question, we have find the coefficient of x power 6 y cube, where the expansion is given as x plus y to the power of 9. So we have a general formula where it says T of r plus 1 equals NCR A n minus r br. So now if you take this formula, we can compare x plus y whole to the power of 9 as a plus b to the power of n. That is binomial expansion formula. So if you expand this, we get a is equals to x, b is equals to y and n is equals to 9. Substitute in this formula, what we have, we get T R plus 1 will be n is 9, 9 C R, A is x, x to the power of 9 minus R, B is y, y to the power of R. Now, what we need to do is we'll compare the values of y R and the question y3, y cube. That is, we get yr is equals to y cube, means R is nothing but 3. The value of R is 3. Substituting in the formula, we get T 3 plus 1 is equals to 9C3, x to the power of 9 minus 3, y to the power of 3. That will be 9 factorial divided by 9 minus 3 factorial and 3 factorial, and x to the power of 6, y to the y cube. Then if you simplify this, we'll simplify here. That will be 9 factorial divided by 9 minus 3 is 6 factorial, 3 factorial. So we can write 9 as 9 into 8 into 7 into 6 factorial. Because we have 6 is a greater number, we'll stop till 6 factorial. Then 3 can be written as 3 into 2 into 1 factorial. So 3 1 times 3 3s are 9, 2 1 times 2 4s are 8. So 3 6 and 6 get cancelled. So it is 3 into 4 is 12, 12 into 7 is 12 sevens are 96. So the answer is 96 x power 6 y cube. So they are asking you to write the coefficient of x power 6 y cube. So what is the coefficient? The coefficient is 96 is the given answer. So for the given question. Okay. So this is how we solve the problem. Now moving on with the next one, we have next equation is show that 1 plus 3 plus 5 plus it is 2n minus 1 terms 2n minus 1 terms is equal to n square by the mathematical induction. So how to solve this by mathematical induction? We have to start by solving. Let p of n is equals to the question whatever they have given, 1 plus 3 plus 5 plus 2n minus 1 is equals to n square. So now let n is equals to 1, first step. So p of 1 will be, substitute n where you have, so 1 in place of n, so we get plus 2 into 1 minus 1 is equals to 1 square. That is nothing but 2 minus 1 is 1 and 1 square is 1. That is LHS is equals to RHS. If both are equal, then we say therefore P of 1 is true. Okay. Then now we'll take let n is equals to k. That is P of k will be 1 plus 3 plus 5 plus goes on till plus 2n minus 1 2k minus 1 2k minus 1 is equals to k square. So therefore P of k is true. Now we shall prove that P of k plus 1 is also true. So now to prove P of k plus 1, what we need to do is we have to find the sequence of this sequence of the series, that is a common difference between the series. So we have the common difference, that is 1 2 3 4 5, means the common difference is like 2. They are leaving 2 the center number and they are writing the next digit. So here we have to see what is the element. Here we have minus 1, so next digit will be 0 and then it will be 1. So the next digit they are cancelling and they are taking the next one. So here if it is 2k minus 1, the next one will be 2k and the next one will be 2k plus 1. So the center one they are leaving and they are taking the last one. So the next term of the given term in the question should be added to it. Okay. So yeah, to prove n is equals to k plus 1, what we need to do? We need to just add the term. So we'll write P of k plus 1 will be 1 plus 3 plus 5 plus goes on till plus 2k minus 1 plus of 2k plus 1. So now whatever we add in LHS, same thing should be added to RHS. So what is RHS we have here? We have in RHS is k square. So add this 2k plus 1. We add 2k plus 1. Okay. So here when you add, it will become k square plus 2k plus 1. Find the factor of 1. One factor is 1 ones are 1. So when you add, it will leave plus 1 will give you plus 2. So here the factor will become k plus 1, and again it is k plus 1. So it is 2 times, so we can write k plus 1 whole square. Therefore p of k plus 1 is also true. If also true. So if this is true, we can say therefore p of n is true for for n greater than or equal to 1, n greater than or equal to 1, uh, for all positive integers. Okay, then moving on with the next question, we have find the fog and GOF for the given function. So we have to find the fog and GOF solution. So what is fog? Fog, they have given f of x is x plus 2, g of x is 2x plus 1. So first we will find fog of x. That is nothing but f of this of is bracket g of x. So now what is f of g of x? What is g of x? G of x is 2x plus 1. Now you can see that this is in the form of formula f of x. So write the formula f of x equals x plus 2. Call this as equation 1. Now compare this f of x and this f of x. We find that x is taking the value of 2x plus 1. Now substitute 2x plus 1 in equation 1. So we get, in place of x we should write 2x plus 1. So here we'll write it is 2x plus 1 in place of x. Then this plus 2 as it is. So it becomes 2x plus 1 plus 2 is plus 3. So fog of x is 2x plus 3. We'll go for the g of x, that is g of f of x. That is nothing but g of f of x. What is g of f of x? F of x value is 2x plus 1. Now it is in the form of g of x. So write the formula. We have formula is g of x is equals to x to g of x. F of x, sorry, here it is f of x. So we need to write f of x value, not g of x value. We have to write f of x. That f of x is how much? It is x plus 2. So now what is g of x formula? It is 2x plus 1. Now we have to compare x value. What is x value here in both? Here we have x and here we have x plus 2. So x will become x plus 2. So now in g, that is GOF of x, f of x, we have to, in place of x we should write this formula, that is we can call equation 2. Substitute x value in equation 2. So we'll get 2, in place of x we'll get x plus 2 plus 1. So multiply this, 2 into x is 2x plus 2 2s are 4 plus 1. So it will become 2x plus 5. So this is GOF of x. Moving on with the next question we have is explain any two types of graph with an example. We have pseudo graph. First type is pseudo graph, a graph having no parallel edges but having a self loop. They should not have a parallel edge, and it should have a self loop. Then it is called a pseudo graph. For example, this is a self loop. Okay, and it should not have a parallel line, then it is called a pseudograph. Then you have multi-graph. What is multi-graph? Parallel lines are what? The lines which do not intersect at any point is called as parallel. So here we don't have any, it is intersecting lines, so it cannot be parallel. Okay, so next one is multi-graph, a graph having no self loop but having a parallel edges in it is called as multi-graph. So here we can have a parallel edge. Okay, we can have a parallel edge, then it is called as multi-graph. And it is, we should not have a self loop in a multi-graph. Okay. Okay, then next one. Draw a diagraph. Digraph. Digraph means directed graph corresponding to the matrix. So we have to draw a digraph for the corresponding matrix. We'll just make this as matrix now. We'll just make it as matrix here. We'll take it as. So let me take this as A, B, C, D. Here it is A, B, C, and D. I'll write it here. A, B, A. One second. Or I'll draw it separately so that you'll not get confused. I'll draw it here. It is A, B, C, D. We have 4. Then here it is A, B, C, and D. First, we'll write the matrix of the given things. Okay. Now they have given it is 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 2, 0, 0. So now we will find A, B. I'll take C and D. A, B, C, D. Now we will start connecting it by the given values. So we have first one A to A it is 0, then A to B is 1. A to B we have 1 vertex. Then A to C we have 1, A to C we have 1 vertex. Then we'll go for the next line B to, now when we don't have any connection, then C to B we have 1, C to B we have 1 connection. Then C to C we have 1, that is a C to C we have 1 connection. Then C to D we have 1 connection, C to D we have 1 connection. Then go for next one. We have D to A 0, D to B is 2, D to B we have 2 connections, 1 and then it is 2. We have 2 connections. So this is your directed graph for the given matrix. Okay. Then moving on to the next one, third main, section C. In section C we have you have to answer any 3 questions. Each question will be for 10 mark, and there will be a sub question. That means each question will be for 5 mark. So here we have first one 21A. We have find the A union B for the matrix for the given set. What is mean by union? Union means you should write all the elements together. 1, 2, 3, 4, 5, 0, 3, and 6. Arrange it in order. So it will be 0, 1, 2, 3. Repeated one write only one time. 4 and 5. Union is nothing but to writing the elements together. Okay. Then what is intersection A intersection B? Intersection is nothing but common. We have to see the common element in both. So what is common in both? We can see common is 3 in both. So the A intersection B is 3. That is nothing but common element. Same element. Okay. Next we have to take for the next one. What is next one? Next one is A minus B. A minus B can be written as A by B. What is A? A is 1, 2, 3, 4 and 5 and B is 0, 3, 6. What you need to do is we need to cancel the terms which are same. 3, 3, only 3 is common, we cancelled. Then we have to write answer only which is there in the numerator. So the answer will be 1, 2, 4 and 5. Then it is B minus A is the same procedure. B will go up and A will come down. That will be 0, 3, 6 divided by 1, 2, 3, 4, 5. Cancel the like term, that is 3 and 3. So the answer should be written from only from the numerator. That will be 3, 0 and 6. So the answer for this will be 0 and 6. Okay, then moving with the next question. Solve the following system of linear equation by Cramer rule. What is mean by Cramer rule? We have to find the determinant of the terms. So let me first write what is the A, what is matrix A and what is matrix B. Matrix A will be all the numbers which are there in coefficients of x. So we have the coefficient of x as 1, 1 and 3. Then we have coefficient of y, that is 1, minus 1, 1, minus 1 and here it is 5, 1, 5. Then z is 1, then here we have 2, and then here we have 7. So it is 1, 1, 2, minus 7. This is your A matrix. Then what is your B? B is the solution part. That is, here we have 8, here we have 6, and here we have 14. So totally 8, 6, and 14. So now to find the Cramer rule, first we should find the determinant of A. Determinant of A will be 1, 1, 1, 1 minus 1, 2, 3, 5, and minus 7. So what we should do for finding determinant? First we should write plus, minus, plus. We will be taking the first element, that will be 1. So it will be plus 1, then you will be taking the cross of this, that will be minus into minus will be plus, 7 ones are 7, minus, this minus is constant always, 5 into 2 is 10. Then we have to take always minus here in the center. Okay, then you'll go for the next one. We have second element. When you take that row and that column, you should leave. So it will be minus 1 into 1 into 7. Minus 7 is minus 7, minus of 3 into 2 is 6. Then you'll go for the last one, that is, you have the last element is 1. So you will take that row and that column, that will be plus 1 into, so here it will be 1 into 5 is 5, minus of minus become plus, then 3 into minus 1 is 3. So here it is minus of minus 3. Certainly minus into minus become plus 3. Okay, so you need to remember this: minus into minus is plus, plus into plus is plus, minus into plus is minus, plus into minus is minus. Okay, then yeah, what we get? Plus 1 into minus 3, minus 1 into minus 13, plus 1 into plus 8. So here by using this operation, what we get? We get determinant values are, it will be minus 3 plus 13 plus 8. So 13 minus 3 is 10, 10 plus 8 is 18. So delta is value is 18. Okay, now we have
So
to
yeah,
find
we
the
have to
next.
find the value of delta x. Delta x is nothing but replacing the first column with the b values, 8, 6, 14. Then it is 1 minus 1, the remaining 2 will be as it is. Now you take simplify this by determinant method, plus, minus, and plus. So if you take first row and first column, here it is minus, it is a plus 8 into minus cross multiplication, plus 7 minus 10. Then minus 1, second one, if you take minus 1 line, that will be 6 into 7 is minus 42, minus 28. Then plus 1 into, if you take the third one, you get 6 5s are 30, then minus and minus become plus, 14 into 1 is 14. Then it is plus 8 into minus 3, minus 1 into minus 70, plus 1 into 44. So yeah, it is minus 24 plus 70 plus 44. So it will be 90 if you simplify. So delta x value is 90. Okay, then you'll go for delta y. What will be delta y? Delta y will be 8, 8, 6, and 14. Then the third one is 1, 2, and minus 7. So now simplify this part, we get plus, minus, plus. So we'll simplify this first row, first column. Certainly plus 1 into 6 into 7 is 42, minus 14 twos are 28. Then minus 8 into second row, the column we leave. Then it is 7 minus 7, minus into minus, it is minus 6.
3 twos are 6. Then it is plus 1, plus 1, last one, last column. It is minus, it is 14 minus 18. So here it is plus 1 into minus 70. 42 into 28 is, it is not 70, sorry, it's yeah, uh, uh, 42, that is 42 into 40, yeah, correct, 70 minus 70, then minus 8 into minus 13, then plus 1 into minus 4. So yeah, it is minus 70, minus into minus is plus, 13 into 3 is 13 into 8. So we get it is 108 minus 4 ones are 4. So it will be minus 74 plus 108. So minus 74. We get 30. So the answer is 30. Delta y. Same way you will find for delta z. What is delta z now? Delta z will be changing the third column. So it will be 1, 1, 3. First one as it is, second one 1 minus 1 5, and the third one that is z value will change. Why? That will be 8, 6 and 14. So now simplify this, plus minus plus. So it will be first row and first column you take. So it will be plus 1 into minus 14 minus 630. Then it will be minus 1 into, if you take this 2, it is 14 into 1 is 14 minus 18. Then the last one plus 8, plus 8 if you take it as that row and column you leave, 5 ones are 5, minus into minus plus, 3 ones are 3. So it will be plus 1 into minus 10, 30, 40, 44. Then minus 1 into minus 4. Then plus 8 into plus 8. So here we get the value is that will be minus 44, minus into minus plus 4 plus 64. So it will be 64, 68 plus 68 minus 44. So it will be 68 minus 44. How much it will be? 68 minus 44, it is 24. So the value will be 24. For the, it is 24. Okay. So now what is x, y and z? Delta x, delta y and delta z. So delta x. X will be delta x by delta. Delta x is 90. So 90 by 18. So 2 4s are 8, 2 5s are 10, 45 times. 2 9s are. So again 9 ones are 9, 9 fives are 45. So the x value is 5. Then what will be y? The y will be delta y divided by delta. So delta y is 30, 30 divided by 18. So it goes in two table, 2 9 times, 2 1 time, 2 15 times. So it will be 15, 3 3s are 9, 3 5s are 15. So it is 5 by 3. Then what will be delta z? Delta z will be delta z divided by delta. That will be 24 divided by 18. So it will be 24 divided by 18 is how much? It goes in again 6. 6 3s are 18, 6 4s are 24. So it will be 4 by 3. So these are the values of x, y and z by using the Cramer rule. Moving on with the next one, we have they've given there is a letter which is L E A D I N G, lead, leading. Okay, so now he's saying we have to take all the vowels together. We have to arrange all the vowels together. We have vowel is E, A, I. What is vowel? A, E, I, O, U is called vowels. Okay, so he's asking you to arrange all vowels in one side. So we'll arrange it. E, A, I in one side. The remaining we'll write it in the remaining box. That will be L, D, N, G. So here how many letters we have? 1, 2, 3, 4 and 5. That will be 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1. That is 120 ways. Okay. Now since we have taken this E, A, I vowels separately, we have to find the solution for them. That is in how many ways that can be arranged. That is 1, 2 and 3. That will be 3 factorial. That will be 3 into 2 into 1. That is nothing but 6. So now the way of arranging all vowels together will be 120 ways into 6 ways. That will be how much? 720 ways is the final answer. Then moving with the next question we have here. Group has students. Okay, so they have given physics, English, and biology. So here we'll take letter P be the students studying physics. Then E be the E be student studying English. Then next one is B be the students studying biology. So yeah, they've given physics is how much? 49. English is 37. Biology is 21. Then 9 students study physics and English. So this maths is given in a wrong way. Suppose if you have attended and you got confused, you may get the grace marks for this because your maths is not there. Okay, so we'll just think that it is physics and English. So we'll take physics and English intersection. You should write when it is common for both the subjects. So it is 9. Then you have English and biology, that is E and B, will be 5. Then physics and biology is 4. Then physics and biology is 4. Then 3 students study physics, English and biology. So 3 students study all the 3 subjects: physics, English and biology. So he's asking you to find how many students are there, total number of students. So yeah, what is total number of students? That will be P union E union B. We can write it as first single terms P plus E plus B. Then two terms will become minus. So it will be P intersection E symmetric you should write E intersection B, then B intersection P. Then plus of all together P intersection B intersection E. Anything you can write P E B or E B, nothing, it doesn't change. Okay, so it is 49 plus 37 plus 21 minus 9 minus 5 minus 4 plus 3. So when you add this all, we get the value for this will be 90, 110, 40. So it is 110 minus how much? It will be 9 and 9 18. So it will be minus 18. So the answer will be 92. So how many total number of students? Therefore, the number of students are therefore the number of number of student in the group in the group in the group will be how much? It will be 92. Okay. Now moving on to the next question, we have find the in show that the given integer is a solving by using the mathematical induction. So this is again, let us take let p of n equals the question 1 cube plus 2 cube plus 3 cube plus goes on till plus n cube equals n into n plus 1 whole square divided by 2. Then let n is equals to 1. So if n is equals to 1, we have p of 1 will be 1 cube plus 2 cube plus 3 cube plus Italy n cube, that is 1 cube equals 1 into 1 plus 1 divided by 2 whole square, that will be 1 cube is equals to 1 plus 1 is 2, 2 and 2 will get cancelled, that will be 1 square. That is 1 is equals to 1 means LHS is equals to RHS, therefore P of 1 is true. Then we will take the next one. Let me take, let n is equals to k. If n is equals to k, it is P of k is equals to 1 cube plus 2 cube plus 3 cube plus goes on till k cube equals k into k plus 1 divided by 2 whole square. Therefore, P of k is also true. Is also true. Now we shall prove that P of k plus 1 is true. So to prove the k plus 1 is true, what we should do is we have to see the last element. It is k. So here we have 1, 3 and 5. That is, it is continuous number. So k means next number will be k plus 1. So we have to add k means next term will be k, next term will be k plus 1. So we have to add the next term for the given series. So it will be P of k plus 1 will be 1 cube plus 2 cube plus 3 cube plus goes on till k cube. Then you should add k plus 1 whole cube. Now whatever we added in LHS, same thing will add to RHS. So it will become is k plus 1 divided by 2 whole square plus k plus 1 whole cube. Now we have to simplify this. So to simplify we can write this as k square into k plus 1 whole square divided by 4. Then plus. So then 4, it is 4 4, then plus, we'll multiply and divide by 4 for this side so that the LCM will be same, whole cube. Now since here square and here cube is there, we can take the common element, that will be k plus 1 whole square. So if I take k plus 1 whole square, it will be left out only, and divided by 4 also common. So it will be k square plus 4 into k plus 1. So now it will become k plus 1 whole square divided by 2 square into k square plus 4k plus 4. So the factor of 4, the last number will be 4. 2 2s are 4. 2 plus 2. So when you add, you get 4. So the factor will become k plus 1 whole square divided by 2 square, and it will become k plus 2 whole square. Because we have k plus 1, it can be factorized in this way. If you don't know, we have to do k square plus 4k plus 4. We'll just break and write this in the terms what we got, k square plus 2k plus 2k plus 4. So taking common in this 2, k is common, so it will become k plus 2 plus 2 k plus 2. So k plus 2 is repeated 2 times, so we will write k plus 2 whole square. So then we have here k plus 1, and here we have k plus 1 plus 1. 2 can be written as k plus 1 plus 1 whole square divided by 2, and the square for all we have, that we can take it as whole square. Therefore P of k plus 1 is true. So whatever we have in the question, in the last we should get the same. In place of n, it should be k plus 1 in the final answer, then it is satisfies. Therefore P of n is true for all n greater than or equal to 1, greater than or equal to 1, for all in natural number, for all the of 1 1 and on 2, that is injective and surjective, then it is called as bijective. So now let us find 1 1 here for this given function.
So to find 1 1, we what we need to do is f of x is equals to 2x minus 2x minus 3. Let f of x1, let x1 is equals to f of x2, where x1 comma x2 belongs to R. So yeah, x1 is 2x minus 3 equals 2x minus 3. So here we have 1 and here we have 2. Then common term 3 and 3 get cancelled. We get 2x1 equals 2x2. Then 2 and 2 get cancelled. X1 equals x2. Therefore, when x1 is equals to x2, it is 1 1. Therefore, f is 1 1. Then you have to prove it is onto. How you'll prove onto? To prove onto, what we have to do is let x belongs to R, there exists y belongs to R, such that f of x is equals to y. Now f of x equals y. What is f of x? It is 2x minus 3 equals y. What is mean by onto is just you have to convert the formula of y in terms of x. We have to write the formula of x. Okay, so yeah, now leaving x, we have to shift everything in other side. So really 2x minus goes other side, become plus y plus 3. Then naturally 2x will be 3 plus y. Then x will be multiplication goes other side, become division. So actually y 3 plus y by 2. So here this is x, or you can write x is equals to y plus 3 divided by 2. If it is we've changed it in the form of x formula, therefore f of x is, that is f is onto. Since f is both 1 1 and onto, both 1 1 and onto, it is bijective. What is bijective? Bijective is nothing but when the function is both 1 1 and onto, it is called bijective. Or even we can write when the function is injective and surjective, it is called as bijective. Okay. So yeah, moving with the next question, we have they express about the adjacent matrix representing the graph. Illustrate an example. So yeah, what is a adjacent matrix? Is a sequence matrix used to square matrix used to represent a finite graph. The elements of the matrix indicates whether the pair of vertices are adjacent or not in the matrix. So if V is the vertex and in the matrix A, then Ij will be rows and columns. So yeah, if there is a vertex here, vertex, that is points are I and j, vertex j. Then if you have there is a connection between the edge I and j, then it is 1. If there is no connection between I and j, it is 0. So here we will just check out. So we have 1 to 1, we have any connection? No, it is 0. Then from 1 to b we have 1, so it is 1. 1 to c we have 1, so it is 1. 1 to d we have 1, it is 1. Then 1 to e we don't have, it is 0. Then go for the next one, it is B. From B, you just check from B what we have. From B, it is B to A, we have yes, we have 1. B to B 0, self loop we don't have. B to C we don't have any. Then B to D we have 1, and B to E we have 1. Then next one it is C. If it go for C, C to A we have 1, C to D we have 1. Then we don't have anything, the remaining will be 0. Then you'll go for D. D you have for A, B, C, D self loop, and then for E we have for all A, B, C, D, and for E. Then for E, if you take, it is only for B and D. So it is connected for B and D. The remaining will be 0. So here the self loop can be written as 2, or it can be written as self loop means it has two values. So you just write it as 2. Now, what is a show that the given graph is isomorphic? I just said in the previous question it was isomorphic. Number of vertex should be same, number of edges should be same, degree sequence should be same, and the length of the given vertex also should be same in the graph. So now we'll take this one and we'll just try to solve. So here number of vertex is points. We have 1, 2, 3,
4, 5. We have 5 points. Let me call this as G and let me call this as H. Okay, matrix H. So here how many points we have? 1, 2, 3, 4, 5. Even here we have 5. Then we will go for the next one. We will check for how many lines we have. So that is edges. 1, 2, 3, 4, 5, 6. So we have 6 here, and here 1, 2, 3, 4, 5, 6. Even this is 6. Now we will find what is the degree of the given graph. What is the degree for both the given graph? So here to find degree, what we should find? We have to find how many lines are connected to that point. So here we have 1, 2 and 3. Here we have 1 and 2. Here we have 2. Here we have 1, 2. Here we have 1, 2, 3. So the sequence will be 2, comma 3, comma 2 comma 2 comma 3. So now we'll check for this 1 2. Yeah, then it is 1 2, then 1 2 3, then you have 1 2, then you have 1 2. So here who we have, it's 2, here it is 1 2 3, here it is 3, so 3, certainly 2 comma 3 comma 2 comma 2 comma 3. So both the degree sequence are same. Then the last one we'll check, we'll check the vertex, that is the length of the given cycle. It should be same, the length of the cycle should be same. If I take the cycle which is let me take the cycle, this one, 1 2 3 4 5 6, or no, let me make it little simple for you. I'll just take this triangle 1 2 3. I'll take this also 1 2 and 3. So the cycle here and the cycle here is having same length, therefore it has the same length, that is 3 and 3 here. Therefore the given graph is a isomorphic. Hence we complete the paper. Thank you students. Thank